For those of you who haven't been to a Sci Cafe before, this is a very relaxed atmosphere. This is more of a conversation than a lecture. And so please feel free to interject, raise your hand, raise your feet, raise your voice. Want to make this a dialogue between our panelists and the audience. Last week I was actually in Chicago for the International Public Science Events Conference. And this is where all the science cafes and all the science festivals, which we have a science festival here in St. Petersburg that I co-founded and co-chair, come together from all over the world. And it's exciting for me because you get inspired with new ideas. And that's dangerous because we all know last time what happened when I went to those conferences. I came back and tried to do some risky topics here. But I think it's very exciting. We're part of a larger movement. There were a number of new sci cafes and new festivals erupting all over the state and all over the world. And so very excited that we have this wonderful consortium of the Ocean Team. Those are the 14 institutions representing over 1,600 scientists in our backyard that are doing really cool research and innovation. And so we need to celebrate that, and you should be proud of having this in your backyard. So without further ado, our topic tonight, Rob, Laura, thank you. Our topic tonight, as you know, is about the bipolar climate. It's a timely topic, especially after being in Chicago last week. The cabbies were telling me that it's the coldest winter they've seen in a number of years. I don't know how to do it up there, to be honest with you. I was happy to return on Sunday to beautiful skies in a convertible to tour around St. Pete. So, this is a timely topic. I mean, there's a question about weather versus climate. I think that's important to understand. And I know Rob has actually looked into some potential discussion items. So I'm going to turn over to Rob. And again, thank you for joining us tonight. And where are Peter? Peter, when is the bar closing tonight?
Actually, very shortly.
Okay, but feel free to get up and refresh your drink, and then it will close. And then again, we have time for discussion during and afterwards as well. Thank you.
Okay, thank you.
Well, hi everybody. I'm sorry I'm late. David, I wish that we had a train going from Tampa to St. Petersburg. And maybe that will come up tonight too, as we talk about this. I want to introduce our experts. Mike Clay is the Chief Meteorologist at Bay News 9. Mike, thank you for coming. I know you're busy. Thank you.
Pleasure.
And Mark Luther is a PhD Associate Professor at the University of South Florida in the College of Marine Science. Mark, thank you very much. So my first question is, why do we have this weird weather this month? Mike, can you talk about that for me?
Well, I noticed you did say weather, and there's a big difference between weather and climate. And it's very important, I think a lot of meteorologists get frustrated, and I'm not a climatologist. I think a lot of meteorologists get frustrated because the two are becoming melded into one. The weather is the climate is your personality, and the weather is how you feel today. Okay, so for the weather to have extremes is part of the global system that is running the planet, that's making rain, that's making the patterns that we have. And around our area, it was in January it was 3.6 degrees below normal for Tampa. But in December, it was almost 5 degrees above normal. And in February, we're exactly normal. So you end up with, it seems like it's been cold, but since meteorological winter began, December 1st, we're actually a few degrees above normal.
I think a lot of people are wondering about what we're seeing at the Sochi Olympics, what we're seeing in California, and for Russia to be warm and Chicago to be what seems to be, as Howard just said, colder than normal. Is this within the range of what you've experienced as a meteorologist?
I think one of the hard things for people to understand is that, well, first of all, with the Olympics, when they announced the sites, there were meteorologists and climatologists whose jaws dropped. And we said, really? Because that's not a very cold place. And then people forgot about it because they announced the sites, what, probably 10 years ago. People forgot about it. Now they're seeing it. So that's not a surprise. I think with the weather patterns that you see, and meteorologists, and I'm not the only meteorologist in the room, we look at the weather every day. I've been looking at the weather maps every day for 30 years. And so to us, a lot of this doesn't come as any big surprise because we see the patterns that are set up, the troughs and the ridges, and that are very explainable with things that we've seen in the past. A good meteorologist goes back and looks at weather history. And when we look at weather history, we see some crazy things that have happened in the past. But a lot of people, weather history is what they remember. And you also have to remember that our weather history is like this compared to the entire history of the planet. So we go back maybe 100 years. We didn't start counting tornadoes in this country until 1950. And we didn't even put them in forecasts until the early 1950s. We didn't even start flying planes into hurricanes until recently. Planes, drop zones into hurricanes didn't get GPS until the early 2000s. So our history of what's going on is very limited.
So, Mark, let me have you pick up on that. Okay, if we've really been studying the weather for the last 100 years, and some of these things that Mike talked about have only been measured for the past 50 years, should we take anything that we're seeing out there today and draw any conclusions?
Well, it's still a difficult problem. That's a difficult question to answer. However, there are really good instrumental records that go back at least 100 years. And there are now a lot of satellites especially, that can measure things like how much water is in the oceans, basically global sea level. And they do see fairly rapid changes just over the last couple of decades. And again, because we only have 100 years, it's tempting to say that it's perhaps due to global warming or some man-made phenomenon, but you can't completely rule out, some natural climate variability. But there is broad consensus that what we're seeing is the result of a steady rise in global temperatures. The ice volume in the Arctic is the lowest it's ever been since they've been keeping measurements of such things. But again, the only way that they get ice measurements is primarily from satellites, and satellites that observe the surface of the Earth have only been around since 1978-79, at least in the precise form that we need them now, or that we know them now. Again, as Mike said, when we talk about climate, we're talking about the average of weather over at least a month, if not a season. And so you have to really understand what's going on now. You have to have a basic understanding of what drives the Earth's weather and climate cycles. And that's why I have this picture up here.
Well, do you want to talk about this?
Yeah. And the physics are fairly basic. The sun heats the Earth primarily in the tropics because that's where it's mostly overhead. At higher latitudes, most of the sun's heat that comes in gets reflected back out into space. But plus or minus 22.5 degrees of the equator, what we call the tropics, the sun is overhead most of the time, so most of that incoming solar heating gets absorbed by the surface of the Earth. Well, if you look at this map, this is global sea surface temperatures averaged over many years. The reds are warmer colors up to about 30 degrees C, 90 or so degrees Fahrenheit. The blues are down close to 0, and the greens are somewhere in between. So in the tropics, most of the surface of the Earth is water. There's not a lot of land in the tropics, a little bit of South America, Africa, and Indonesia. The rest of it's water. And water has a very, very high heat capacity. It has the ability to store large amounts of heat without changing its temperature very much, whereas land has a very low heat capacity. Most of the heat is absorbed by land during the day gets radiated right back out into space at night. I always use the analogy in my classes that if you've ever walked out on the beach in the dry sand in the middle of the day in the summer, the sand will burn your feet. You run out into the water feels relatively nice and cool. You go back out that same spot on the beach at midnight, the sand is now really cool. You walk out in the water, it's the same temperature it was in the middle of the day. That's because of the high heat capacity or the high heat storage ability of water. So most of that heat coming into the earth is absorbed by the ocean, it's moved around by ocean currents, it's radiated back out into the atmosphere, and that exchange of heat between the ocean and the atmosphere is what drives weather patterns. And the difference in heating between the oceans and the land also drives weather patterns. So that heat has to get, for the Earth's climate to be in balance, the heat has to get from the tropics to the poles in both hemispheres to be radiated back out into space. So there's this constant transport of heat from the tropics toward the poles where it gets radiated back out into space. Part of that heat transport happens due to ocean currents. There are strong ocean currents like the Gulf Stream off the east coast of the U.S. that carry warm water poleward, where it again radiates that heat back out into the atmosphere or exchanges that heat into the atmosphere. But then weather patterns also transfer a large amount of that heat poleward.
Hurricanes.
Well, that's one of them. And yeah, hurricanes carry a lot of heat away from the tropics towards the equator. So that exchange of heat between the ocean and the atmosphere sets up these gradients in temperature patterns in the atmosphere. We call the subpolar front being the main one, the polar front. So right around the northern U.S. Canadian border, on average, there's this large contrast between the warm tropical air masses and the cold polar air masses. We go to the next slide. I think I got another one here that illustrates that. And so along that contrast, we call it a front in meteorology and oceanography. There's warmer air to the south of that front and colder air to the north of that front. So the warmer air, there's generally higher atmospheric pressure. Under the colder northern air, there's generally lower atmospheric pressure. And because of the Earth's rotation, air wants to flow downhill just like water flows downhill. So air wants to flow from the higher pressure towards the lower pressure, but because of Coriolis, the Earth's rotation, it gets deflected to the right. And so along that front, we have this very strong thing we call the jet stream, very strong winds, 100 miles an hour up at the upper part of the troposphere that goes along that front, okay? So, the stronger that heat or that temperature contrast between those warm tropical air masses and those colder polar air masses, the stronger that jet stream is. But that jet stream is, and that whole frontal system is inherently unstable. So when it becomes unstable and wiggles north and south, that's what we call weather. Let's see. So when that front wiggles to the south and the jet stream wiggles with it, that's a cold front that dips down into the continental U.S. When it wiggles to the north, that's a warm front that carries warm air up into Canada and the Arctic regions. And so whenever that frontal system and that jet stream wiggles north and south, we call that winter storms or extratropical cyclones. That transports heat poleward that helps maintain this global heat balance. Now, if indeed the poles, the polar air masses are getting warmer, which they certainly appear to be over the last several years, then that gradient becomes weaker and it allows that front to wiggle more and carry more cold polar air farther south into the eastern U.S., like on the right side here, and more warm tropical air up into the Pacific Northwest, which is part of why we're having droughts in California right now. And so you get into this situation like we've been for a lot of this winter, where the jet stream is meandering very far to the north over the eastern Pacific Ocean, western continental US and Canada, and then dipping way down into the eastern US, bringing all that cold polar air southward, causing a lot of the cold weather that we've been experiencing. And so all of the predictions, mostly based on large climate models, or basically weather models that are run for very long periods of time, predict that as those polar air masses get warmer, that gradient between tropical air masses and polar air masses gets weaker. We're going to see much more of these kinds of patterns. So
Mark, I want to know about what evidence there is for the warming of the planet. There is rock solid evidence, and I'm thinking of average annual temperatures, I'm thinking about what's happening at the poles, I'm thinking about the Maldives and places like that. I mean, what is the evidence?
well, there is some evidence, again, good measurements in the oceans have only been available since the 60s. Good temperature measurements over land go back to the Industrial Revolution at least. But again, most of those many of those can be aliased by the heat island effect. As cities have built up and more paving, more asphalt, there's more surface heating there because of those structures. So some of those records are somewhat suspect. But if you take them all together, there is definite evidence of a rise in global temperatures over the past few decades. And it seems to have accelerated over the past few decades. Again, measurements of sea level are available for 100 years here in the eastern Gulf of Mexico, 200 years in parts of Europe. And those sea level records show a steady rise of about 2 millimeters a year for most of the 20th century, but just over the last 2 decades, there seems to be an uptick in sea level rise of somewhere around 3 to 4 centimeters a year. That doesn't sound like a whole lot. I mean, 2 centimeters, 2.5 centimeters is an inch. But it's a steady rise, and most of the models predict that will increase. The volume of ice in the Arctic has decreased dramatically over the past few years. The ice contained in glaciers around the world has decreased dramatically over the past several years. And so all of that helps to raise sea level. Ocean temperatures in some areas appear to be getting warmer. In other areas, they may be getting colder, but on average, the ocean appears to be warming. And so warmer water expands and stands higher. So that's part of the rise in global sea levels, is simply a warming of waters.
So, Mike, let me go back to you for a moment. Are you skeptical? I mean, do you think that this would fit into a cycle? Because if we are just, at the point where we've begun measuring this 100 years ago, what's your take on whether or not it could be explained through normal cycles of weather?
I think anything in science, your first thing is to be skeptical. That's the nature of science. I want you to prove something to me. One of the first things that I learned in meteorology, in synoptic meteorology, one of my first professors walked in and he said, rule number 1, never believe another meteorologist's forecast. And what he was saying is, you sit down and you figure it out yourself. And then you go in, and if your forecast is like his forecast, then you have some consensus and you go from there. So, yeah, I believe a good, healthy skepticism is good. I'm always very critical of some of the records that we have. And I'm always very skeptical of some of the records that we have. And I just think it's good to be able to go in and be able to challenge these things and to be able to go in and say, okay, really? Well, then prove it to me again.
One of the records that I keep hearing from people who are believers in global warming is they say, we've been measuring sea level at Key West for the last 100 years. And if you look at the last 100 years, that sea level rise at Key West has been measured at 9 inches. And then we all know about the studies around here in the Tampa Bay area, extrapolating from that by the year 2100, here in the Bay Area, we're likely to see sea level rise 2 more meters here in the Bay Area. So to that point about Key West and 9 inches, what's your take on that?
Well, again, I'm not an oceanographer, and so I wouldn't have an explanation for that. I've seen some things in temperature data that I'm skeptical about. Tampa, we have probably a heat island effect going on at the Tampa airport temperature sensor. On a cold, clear, calm night, how's it 4 degrees colder at McDill? How's it colder at St. Pete Clearwater than it is at Tampa International? So obviously there's something going on there. So are we getting, as meteorologists, we're like, are we getting the right information? We're always asking those questions. We're always, why is it so cold in Brooksville? What's going on? We always want to know we always want to make sure our data is good. That's very important to us. We want to make sure that we're measuring things correctly from the beginning. And so we look at weather records, and we look back at some of the things. I used to work in Waco, Texas, and Waco was always the hottest place in Texas. And it would drive us crazy because we would forecast 105 and it would be 109. It would drive us crazy. Then the Weather Service office closed, and they moved the weather station to the other side of the airport, and now Waco's never the hottest place in Texas.
Mark, what about the numbers for Key West? 9-inch rise over the last 100 years.
Well, that's a significant rise, and we just published a paper that shows that it's not just the average sea level that's changing, but it's the change in the annual cycle in sea level. There's a natural change in sea level between summer and winter. In winter, the water gets colder. Colder water doesn't stand as high, so water levels are typically lower in winter. In summer, the water is warmer. Warmer water is less dense. It stands up higher, so sea level is a little bit higher in summer. Well, we have a visiting scientist from Germany who's done similar things in the North Sea, looked at the tide gauge records from all around the Gulf of Mexico and found that not only is there this gradual rise in sea level that seems to have increased over the past 2 decades, but the amplitude, the size of that shift between lower winter water levels and higher summer water levels has increased over the last 2 decades by a fairly large amount. 5 centimeters higher in summer, 5 centimeters lower in winter than on average. And so if you're looking at things like storm surge, well, those typically occur from hurricanes during the summer. And so you add a few meters of storm surge onto now 10 centimeters higher water in the summer, then you're talking about potentially much increased coastal inundation, coastal flooding. So yeah, I believe those.
And that's a huge problem. I mean, you live in a hurricane belt, and it's hard to talk about in February when the weather's beautiful and it's 70 degrees. But it's you just can't ignore that climate fact that we do live in a hurricane belt, and we're sitting here, a couple feet above sea level right now.
We'll take a few questions, but
Well,
yes.
I just want to respond to your 9 inches. 9 inches. 9 inches in sea level rise in Key West over 100 years. So 9 inches over 100 years is 2.2 millimeters per year. That is the historical global sea level rise number. So the Key West is a very good measure of the historical sea level rise. When you do the most precise measurements and the satellite global sea level rise measurements, and you look at what has happened through time, that rate is increasing. So if you just look over about the last 20 years, it's gone up to 3 millimeters per year. The difference between the 2 and 3 can be explained by melting of the Arctic ice and the glaciers and Antarctica, mostly Greenland and the glacier melting and increase in temperature. So we've gone from 2, which is what you see in the long term at Key West, to now 3. And given the best models that we have, increased ice melting, increased temperature, increased volume of water, that rate will continue to accelerate. Exactly at what pace is what people are debating now. If we proceed on the business as usual path, then, and Greenland doesn't catastrophically melt, then it's not going to be 2 meters sea level rise by 2100. It'll be more like 2 to 3 feet. So I don't know, the 2 meters is a really extreme view. So I just want to...
Okay, well, thank you for that. And could you tell us who you are?
I slept in the Holiday Inn.
You're stealing the show.
I'm Jackie Dixon. I'm the Dean of the College of Marine Science. I'm
Mike, I want to ask you a job. I'm going to base, I want to go to the audience and get the rest of the questions because I know a lot of people want to ask questions, but I got 3 more questions. And it's because I watch a lot of TV, I've got to ask these questions, Mike. And this did not happen on your channel. But
Okay, go ahead.
I heard, and I'm not going to call out the news organization, but they say that this idea of a polar vortex was designed by people who want you to believe that there is global warming. So they come up with this new concept of polar vortex. Could you talk about that for a moment?
Okay, well, now I get back into weather. The polar vortex is nothing new. It was first showed up in literature in the 40s, and then it showed up a lot in the 50s. Basically, it's just an upper level low that usually sits around Hudson Bay, and so it would be about where the word pressure is here on the map. And it's going to come. It's actually going to dip back down again. It's amazing how that term just took off in media in like a day. Back during the cold outbreak in early January, I mean, I've been watching this for 30 years. The upper level low, it's not something at the surface. It's in the upper atmosphere. It's a cold pool of air in the upper atmosphere that exists mainly over the North Pole. And because of the way the upper level pattern goes, the systems form around it, and you have little upper level lows sometimes that break off. One of those is about to happen. And when that dips down, it brings this trough down into the United States. The trough can be on the west or the east side, but it's all part of the waves around the globe that are constantly changing, and ridges and troughs form. And the polar vortex was a part of that came down for a couple of days in January. It didn't come into the United States, it came down into Canada. But whenever it does that, it pushes the trough all the way down, and that's how we get cold. It happened big time in 2010 when we were so cold in January. So the polar vortex is not, a guy took a picture from Chicago. Hey, look at the polar vortex, I can see it. The polar vortex is nothing at the surface. It's a pattern in the upper level, and it's certainly nothing new. But boy, did it surprise me when someone mentioned it, and it just took off in media. It's not the cause of a cold outbreak, but it sort of is. Let's say you have an upper level low in the southwestern U.S., and you have a tornado outbreak in Oklahoma. Well, the upper level low certainly contributed to the tornado outbreak in Oklahoma, but the tornado outbreak wouldn't have happened unless other things happened. So one of the things that's frustrating for a lot of meteorologists, a lot of times people try to blame the weather on one thing. They don't realize how complicated the atmosphere is. It used to be El Nino. El Nino and La Nina was the cause of everything. And then we had one of our coldest winters with an El Nino. So the weather is extremely complicated, but the media always wants to just latch on and say there must be a cause. And the cause is the polar vortex or the El Nino or something like that. Unless you sit down and do a forecast every day and you're wrong and you figure out why you're wrong and you try to do better next time, and then you beat everybody else and you're really happy because you pat yourself on the back and 2 days from now Mother Nature will show you who's boss. Unless you do that, as a meteorologist, you really don't understand how these patterns go across the country and across the globe, and how we see these ridges and troughs and how they move and how they affect our weather.
And how long have we been measuring this kind of event, the polar vortex?
Oh, well, I guess upper air data would go back, gosh, Charlie, what, to the 40s? Or when did we start really launching the balloons? And
Yeah, back during the 40s.
yeah, I would say really about, Charlie Paxton here is the Science Operations Officer at the Weather Service in Ruskin. And yeah, I guess about in the 40s is when we started. We really kind of discovered the jet stream during World War II, and modern meteorology took a big leap forward because it had to, because it was forced to. And that's when we really started. Before that, everything was sort of measured what's going on at the surface. But then we really started looking at what's going on in the upper atmosphere in the 40s and 50s.
Mark, let me ask you one more TV question before we turn it over to the audience, and that is, on Sunday, I won't say the network, but I was watching very respected No. But because I think we should judge it on the merits of the argument, as opposed to what network it was. So this guy who's a well-respected columnist says that anytime you hear scientists say the argument has been decided that global warming exists, that climate change exists, you know those scientists are losing the argument because they put their foot down. That wasn't his words, but that was what he was getting at. He said, when you hear scientists say that the debate is over, it's a fact, it's a reality. I mean, what are scientists saying? What is the scientific community saying about global warming?
Well,
What are the politicians saying?
Well, again, scientists deal in facts, and all of the facts support that our climate is changing, and is changing more rapidly over the past decade or two than it has over previous decades. Now, whether or not that's due to increased CO2 or something else, you can't deny that it's changing. And if we're going to be smart about it, we're going to err on the side of caution. We ought to be doing something about it now and not waiting until we're absolutely certain that we're all screwed. But again, there's almost unanimous consensus that the climate is changing, and it is most likely due to increased CO2 and other greenhouse gases in the atmosphere. The few climate deniers that are out there can almost always be traced to funding from the fossil fuel industry. Just because you worked on t-shirts for all those years. I agree. But again, you know, what is it? One of the most recent studies is 99-point-something% of all studies done support that, yes, the planet is warming and something is going on. But again, there's that fraction of a percent that's still, and I agree with Mike, we have to be skeptical, and that's the scientific method. And we try to poke holes in all of these conclusions as much as possible through the whole peer review process and everything else. But the fact remains that the planet's getting warmer.
Okay, now we haven't talked about causes or anything, but let's start taking questions. Sir?
Yeah, my question about the currents. Salinity, CO2 has another effect on the oceans that no one's talking about. Carbonic acid. You have a requirement to have a certain density of cold water or dry. That's the differential that drives the current. Now, if in turn we build up high volumes, we say build up, it's at what level buildup does that become critical with respect to the currents? And my question is, when that happens, things are going to get really bad because you're not going to be able to move through the ocean at the rate you need to.
So you're talking about something like the Gulf Stream shutting
Yeah,
down because the convection is no longer working.
Well, it's exactly right. In other words, CO2, everybody talks about the atmosphere, but I'm looking at it from the standpoint of what it's doing to the gradient in the water. And that could be an important effect. And as the dean said, they're going to be effects that will accelerate this thing. We're projecting based on a linear type of projection perhaps. But that can accelerate much faster than we think. And I'd like you to comment on that.
Again, this is not my field, but I'll try to answer as best I can. There is strong evidence that the oceans are becoming more acidic, and that's affecting a lot of marine life that builds calcium carbonate shells. Oysters in the Pacific Northwest and coral reefs in the Caribbean are being affected by ocean acidification. There is strong evidence from deep sea cores and ice cores and things like that of abrupt climate change in the past, where this, what we call the global ocean conveyor belt of warm water being carried poleward by currents like the Gulf Stream, then cooling and sinking in the Greenland, Iceland, Norwegian Sea, and then flowing back towards the tropics and the very deep parts of the ocean. And that accounts for a lot of that global heat balance that I was talking about. There is evidence in some of these deep sea cores that in past climates that has shut down and led to rapid onset of ice ages, which is sort of counterintuitive, that warming melts the glaciers and the polar ice caps, that causes large freshwater lenses that shut down the formation of that deep water, that shuts down the conveyor belt, that kicks us from a warming state into an ice age state. But again, the scale over which that happens is typically, again, this is not my field, so Jackie can chime in if I misstate anything here, that happens over a fairly long time period. It's not like, what was it, the day after tomorrow, where the ice age happened in 2 days. It doesn't quite happen that way, but it does happen rapidly in the scales of climate and geologic times.
Are there any measurements about gradient, the effect of the gradient? Is anyone looking at that right now? I mean, we shouldn't be talking about global warming, we should be talking about climate change.
Exactly, and that's, global warming I think was a misnomer, and it turned a lot of people off. What we're seeing is climate change. The climate is changing, the climate has always changed, but what we're seeing now is unprecedented in the geologic record. There are programs now where there are these fleets of robotic floats, basically, it's called the Argo program. If you do a Google search on Argo, there's 3,000 plus of these autonomous floats that bob up and down over the upper few thousand meters of the ocean, making temperature and salinity profiles. And there's some very interesting research. I'm not up on the latest literature, but those people are looking at precisely the kinds of questions that you're asking. The data record there is very short, but there are some encouraging, or perhaps some discouraging signs there.
Did I hear a skeptic over here? Did you have a question? Because
No name calling.
okay. Well, I meant skeptic in the best sense of something.
I don't have a question, but I mean, I don't think you need to impugn certain studies by indicating that they're funded by a particular industry, because you could go to the other side and indicate the funding for most of those that started this argument came from international groups that were trying to make the U.S. pay for all of the sins of a bunch of other.
You know, I heard something interesting today I'd never heard before, that there's a theory in Texas, my home state's been savaged by drought in the last decade or so. There's a new theory that the factories in Mexico are causing the drought in Texas by putting the pollutants in the atmosphere, which would come from the south. The air masses would come from the south, and that they're thinking now that the pollutants in the air over Texas is causing the rain not to form. And there's actually some scientific basis for that. So, you know, boy, you never know where this is going.
there are still lawsuits going on that were brought by New England states that indicated that the air masses from some of the southern states transported coal particulate and other pollutants into their states. We don't know the answer. They've not been resolved.
Okay, next question.
Looking at your map with the waves, is it reasonable to assume that those waves are maybe changing in highs and lows and in width, but are they regular?
Yeah, they always constantly go, and if you get a zonal flow, which is west to east, you better look out because there's going to be a big storm on that gradient, on that zonal flow. And then if you do get a zonal flow, eventually a trough will build. That's what's happening right now with the weather.
So basically what you're saying is that if we could somehow predict the highs and lows.
We've got pretty good models that go out about 7 to 10 days. The best are run by the European Meteorological Organization. The probably 7 to 10 days is about as good as you're going to get. There's one that goes out maybe 14 that is basically after 7. We call it meteorological porn. Fun to look at, but it doesn't mean anything. But so for about 7 days, we've got a pretty good idea. And then there's some long range stuff, but really 7 days.
But then the logical question is, can you overlay multiple years and see a pattern?
Mm-hmm. Yeah, certainly. Yeah, and there's somewhat of a pattern of chaos. There's always these crazy things going on in the upper levels. Yeah.
And Ed Lorenz back in the 60s wrote a paper showing that there's a fundamental limit to predictability in the atmosphere because it's inherently unstable and chaotic, and that's about 7 to 14 days. And beyond that, even if a perfect atmospheric prediction model would diverge from reality exponentially.
And a couple of weeks ago, 24 hours was rough. On that Friday when it rained, man, was it supposed to? That was a big fuss.
Okay, so let's.
Charlie's over there. Sure.
Charlie,
That said, how can we believe the climate models?
Lorenz also showed.
See, that he's a meteorologist, and that's why he doesn't have any hair. And mine's turning gray because we sit there and we look at these models and we go, "Oh my goodness."
It goes back to Mike's earlier comment. Weather is how you feel today. Climate is your general personality. We can predict that December is going to be colder than July pretty accurately. So we can predict what's called the envelope of the weather patterns. We can predict, on average, is December of next year going to be colder or warmer than normal, or than the long-term average for December's? Pretty well now. But we can't predict what the weather's going to be on Christmas Day with any reliability until about a week ahead of time. But again, we can say on average whether next winter is going to be warmer or colder or wetter and drier with a fairly high degree of accuracy because again, we're talking about the average over weeks to months, and that has much greater predictability.
A lot of times with that, we use what we call analogs. So we go back and we look, anything you're talking about that far out, they do this a lot with long-range hurricane forecasting. They go back and they look at years where the pattern has been like this and then what happened. So they'll say 1962, 1950 was an analog for this year, and in 5 of the analog years we had above average hurricane activity. So then the forecast will come out. So they use the analog sometimes to look at the current pattern to forecast what might happen in the future. In 100 years, people might think that was pretty archaic.
Isn't that how you come up with percentage of chance of rain?
No,
You don't come up with an analog?
climatology is a small part of it, but no, we look at all the computer models that are run every day, twice a day at the Weather Service in Ruskin and about 200 other places in North America. They launch a weather balloon. And the weather balloon goes up, and it gives us all the measurements of humidity and wind and temperature all the way up through the atmosphere, and that's all ingested into the computer models, and they are run anywhere from twice a day to 4 times a day. So the new trend in doing that in meteorology has been what we call the ensembles, because no model can perfectly model the atmosphere. It's impossible. So what you look at is you run a bunch of models, and you change the parameters initially slightly, and if all those models come up with the same idea in the end, then you have a pretty good forecast. This is really catching on in tropical meteorology, and it's about to start catching on in convections, thunderstorms, and severe weather, and things like that. Storm Prediction Center in Norman, Oklahoma is starting to run some ensembles. So I think is getting away from climate and getting back towards weather. That's really going to be very interesting to see where that goes, because we're realizing, 10, 15 years ago, everyone said that the key to forecasting the weather with computer models was to have a higher resolution. And the resolution kept getting smaller and smaller. So, when you get your smartphone out and you go on and you say, well, this has got the weather forecast for my block, you have to realize that smartphone may be using a computer model that the resolution's 54 kilometers or 20 kilometers. So, we're not that good, okay? The computer models keep getting smaller and smaller with the resolution. The computers keep getting bigger and bigger and bigger, and the models are like the blocks of the carpet here around the globe or over North America, and the resolution just keeps getting smaller and smaller, and the forecast doesn't get that much better out of them because their resolution is getting so good that they don't know what to do. Let's say a more coarse computer model, a thunderstorm goes up over Tampa Bay at 3 o'clock in the afternoon. The more coarse computer model may ignore that, but the higher resolution may see that and go, I don't know what to do with this. And so it starts making other things. It turns out to be wrong. So the people that build these computer models are incredibly smart, and the smartest on the planet. They're working on these problems. But it's amazing to me, being in it so long, to see how, we go off in different directions. So it's a hard process.
Okay, who's next? Sir?
I have a question. I live in New York. I read the Times every day. And my friend is a Tea Party guy. I shouldn't quote him, but I will. He says this is called junk science. And I'd be curious to know what your comments are as far as what he thinks is junk science.
Seriously.
It's hard to argue with people who
That's what I say.
who reject facts and only work on their gut feeling. And
That's why I vote.
It's the whole Stephen Colbert thing. I feel it, therefore it must be true. It's the best science available. It's not junk. And again, scientists, we're our own toughest critics. You should read some of the reviews we get on some of the papers we try to get published. We tear each other to shreds, and we stand up and shout each other down in our scientific meetings at times on some of these topics. But in the end, the truth comes out, or at least our best approximation to the truth. And that's what the skeptics always harp on, the uncertainty. Well, if there's uncertainty, then you must be wrong. Well, that's not exactly the case. There's always uncertainty in everything we do, and you try to minimize that uncertainty and then find some consensus as to what the truth is.
I'll go back, and this is as controversial as I'm going to get on this, but I'll go back. Dr. Gray, Colorado State, the hurricane long forecaster that came out, he's about 90 now, and he's at the end of his career. You all know him. You know what he told me about all this years ago at a hurricane conference? He goes, the whole global warming climate change issue got screwed up when the politicians got involved. And then it became polarizing. And the science stepped away. And so that's all I got to say about that.
Okay, who's next? Let's go back.
Just the concern I have is about the thawing of permafrost, which I believe has roughly large volumes of methane, about 72 times more effective greenhouse gas than carbon dioxide. Probability of having a large rapid thawing feedback loop kicking in.
That's way outside of my realm of expertise. I've read sort of popular science articles about it, and it certainly seems frightening, and yes, we seem to have lost a lot of permafrost from what I have read, but again, that's way outside of my sphere of expertise. I really can't comment.
Okay, next question, Matt.
You mentioned that the sensors at our airport are inaccurate, and I wondered why that hasn't changed.
I think it's e-island. Look around Tampa International, look at all the highways and the bridges and everything that have been built and all the concrete and things like that. And I don't think it's all of them, but I think in that particular case it is. We've always, you've heard of these contests, these forecasting contests. We add a couple degrees for Tampa International just to be right. Yeah, if you think it's going to be 32 tonight, you better make it 35 at Tampa International.
Why don't they just change the position of the...
Well, because it's at the airport. Well, if you move it, because the primary reason for it is support aviation. Yeah.
So they need to know what's happening right there.
And the FAA could care less what the temperature is. They want to know the visibility and the wind and things, and the altimeter setting and things like that.
I understand. Thank you.
And if you change it, you screw up the temperature readings over the decades because you change the location of the...
You do, and that happened, back many years ago. Like I remember downtown Miami, they took the temperature sensors on top of a building downtown for many years, and then they realized that was a really bad idea. And then they moved it to the airport. The airports used to be out in the country, so everybody thought that was a good idea. The one that gets you is Pinellas, because the temperature sensors at the airports are on the water. Yeah, and that's the one that gets people that aren't familiar with the area, because you can have frost 2 miles away from the water and 35 degrees and it's 42 on the official temperature. That's the rough one.
Okay, we've got two questions here. First in the second row first.
Well, my question, I'm glad you touched on political, so I won't even go there. But the word that I want to throw out is apathy. I'm not a scientist. I can't discuss all of this. I read the newspapers. I do believe that there is climate change. But then I watch the evening news, and you can tell me that it was 2 degrees warmer in winter here than it was in Tampa today, and I go, how does that benefit me? But when it comes to the climate change, what do we do? I mean, how can we address that? I mean, and that's where the apathy comes in. And I think for the average person, like you said, the average person wants it explained very simply. Right. And I understand that you can't do that. But one of the things that I can't argue with is when you start looking at, carbon emissions, and you start looking at what countries, what parts of the world are, putting most of that in there. Even if we got both sides of Congress to come together and we're going to put a plan together, it would have no effect over what's really happening. So how do you keep apathy from just, everybody just saying, oh, well, we're going the way of the dinosaurs?
Well, and speaking of the Sunday talk shows, which went crazy on this topic, and that was one of the big criticisms of one of them, because the moderator tried to advance it, and apparently the blog I read unsuccessfully tried to advance the discussion to what you're talking about. Okay, what do we do? And and the people on the show just kept coming back to the same old polarizing no, yes, no, and the discussion was never advanced. And I get what you're saying. Yeah. I mean, I agree with you. What do we do?
To me, we haven't really talked about it. Could I just ask quickly, CO2, is it? I mean, how sure are we that it is the cause if we're seeing these temperatures rise? How sure are we that CO2 is caused? Or other greenhouse gases, too?
Well, there's certainly been a huge increase in atmospheric CO2 over the past several decades. That's, again, unprecedented in the geologic record. And CO2 is one of many greenhouse gases. The biggest one is water vapor. So a little bit of CO2 raises the temperature a little bit, more water evaporates out of the ocean, and the atmosphere can hold more water vapor, so that exacerbates the entire cycle. And so, again, it's outside of my sphere of expertise. However, there's a lot of people who do look at this that are very confident that CO2 is a major contributor to global warming.
Okay, next question. Who's at their hand up for the water? Back here.
Yeah, my name is Rennie, and I took a class through University of Toronto. It's how to discuss climate change. 3 things I came away with. The class was global, and there were discussions with people from all over the world. And one of the main things was that the U.S., everybody had the problem of climate change. However, the people in the class who had the most difficulty, the people in other countries recognized it was a problem. Unlike in the U.S., we're still debating the problem, they're recognizing there's a problem. They still have, how are we going to deal with the problem, how that's going to happen, but at least it's yes, this is happening. The other thing is, it is very complicated. As you pointed out, the weather's very complicated, the climate's very complicated, how this happens is very complicated. The fact that CO2 is going into the oceans because of all of the patterns of weather is very real. And you can see it, it's because of the, as you know, because of the coral reefs, they're dying as a result of, and I'm not a scientist, but I know that I was presented with the science that understanding that coral reefs will, because there is CO2 in the water, more than there has been, they will die. Because they have to pull things from it's another mineral from someplace else, which I can't even go into. But anyways, those are the pieces. It's just that in this country, we are still at the place, because of the politicians, that we are not discussing climate change as a reality. Climate change is a reality all over the rest of the world. If you go down south to Key West, that Key West area, there's all kinds of mitigation strategies happening, mitigation to prevent further climate change happening in many, many, many countries. And I know it's happening here at the top levels, it's just not being discussed. We are having mitigation strategies, and we have to, because we're at that place.
I think the problem is, and I think you alluded to this, there are a couple of big countries that aren't doing that. Yeah, China and India.
Oh, they have mitigation strategies.
Right.
No, they're putting up a coal plant every week without controls on it.
But they have some other mitigation strategies, because some of the people, the students in the class, provided the mitigation strategies that were there.
Well, they're like 500 years behind the United States in terms of that particular issue. But the point is, it all comes down to one thing.
What's that?
Cost and money and who pays. That's what it has to do with. So you cannot have a rational public policy discussion on this subject when you're light years ahead of most of the causers, and they're looking to you to pay.
Well, that's a political discussion.
Well, that's what the whole problem is. I mean, it is a political discussion.
It always goes down to economics.
What about with climate change? Maybe there's climate control by another country. Do you remember? I remember hearing something about this years ago.
I don't think.
I won't mention the country.
People underestimate how difficult it is to even understand the atmosphere. We can't even model the atmosphere for over 10 days.
Sir, just so I understand where you're coming from, are you talking about chemtrails and seeding clouds and that sort of thing?
I think a little bit further than that. If you're able to do that, I remember a period in time where I had heard about climate control by a country.
Which country?
Probably, but I'm not.
Probably Russia.
I don't think you understand how difficult it is to, what a gigantic thing the atmosphere is.
But I mean, if countries and their factories and all this that's going up there can do it, I mean, it seems that there must be a way.
Well,
I
are
think
we talking about millions and millions and millions of cars and thousands of factories versus one project by a government. I mean, it seems like there would be no match between
Well,
the
you know,
millions of cars and the thousands of factories in one project.
Over the last 5 years, we've spent billions and billions and billions of dollars in this country focused on researching and improving certain types of renewables. But we've spent virtually nothing for conventional fossil fuel controls, which can be done because they are being done. But you've got to do it on a much larger and more efficient basis so that they're commercially feasible.
So you're making the argument for clean coal and...
I'm making the point that a lot of this is possible, but you've got to not have your favorites about what is the best way to do it. You have to put it all on the table and see what we can do, because as much as you'd like to have renewable energy be able to provide you with the amount of electricity that you'd like to have every time you flip that switch, it's never going to be anything more than an incremental improvement. Unless we do something majorly significant with solar, and that's becoming more and more feasible.
So you
But
have
you've
dragged
got
us
to worry
in,
about more conventional
you have
things.
dragged us in a really political direction. And
Well,
I'm happy,
See what Dr. Gray said?
I'm happy to go there, and
The people are worried about it. People want to know the answers.
My
It
guess
is a
is-
political question.
my guess is that there are people in this room that might like to respond to you, but I don't know if we should go there. But would anybody like to respond to what you just said?
Well,
We've got 3 people with their hands up. You want?
I lived in Taiwan, and Taiwan became one of the most polluted, and it's a small island, most polluted place anywhere. People, it was so bad, they would wear masks to go to work, surgical masks to go to work, because the air pollution was so bad. And what was causing their air pollution was not the Taiwan country itself, but the companies over here that did not want to have to abide by the pollution controls and regulations that we have. They keep trying to keep our country from getting that way. We're setting up operations in Taiwan and polluting Taiwan. And this is happening all over the world because we're so global. We have companies here, as long as the other countries do not have the regulations and limit the pollution like we have, the other countries are going to end up polluting everybody.
We're starting to get some of that pollution back on the West Coast from China.
All right, so we've got a hand up in back. Sir, do you want to?
This isn't a fact that I know for sure, but I think it's pretty, close to being right. That the per capita, we have the largest carbon footprint of any nation in the country.
Oh,
Everybody's reasonably in agreement with that. We also have the most resources that we could direct toward correcting that. Assuming we did, and not extending it out to the industries that we have in other countries, would in 10 years, 15 years, 20 years, we could roll back, our carbon footprint to something more reasonable. How much, if any, significance would that be to the greater problem? Luke, I find that.
Okay, I'm not going to answer your question because I don't know the answer. But I'll be honest. But there are things that are being talked about, and meteorologists are having these discussions. With global warming, it doesn't necessarily mean more storms. And it doesn't necessarily mean the storms will be worse. If the atmosphere, in theory, if the atmosphere is warmer, you won't have the cold and the warm boundaries and the collisions that are needed to make storm systems. And there are some really interesting theories that there will be fewer hurricanes. Gosh, we haven't been hit since 2005 in Florida. So, you have to wonder if some of that's already underway. The Atlantic and the Pacific have been really quiet in the last few years, so you have to wonder. And that's what you were talking about also with transporting the heat north from the poles to the poles. That's a very important thing, is the whole natural process.
Mark, do you want to jump in on that point?
You don't have a good answer either. Jackie thinks you might.
Jackie, do you want to?
If you look at the most recent IPCC report, the International Panel for Climate Change. Big international reports. Go online and Google IPCC. They have a lot of different models with different assumptions. And one of the assumptions is business as usual. We don't make any changes. We continue emitting at the rate we are. And then
Is this just the US or just the world?
the world. And carbon emissions remain the same. Then by 2100, the temperature change is, I think it's 5 to 6 degrees C, which, degrees C. Okay, it's a lot. That means that if you live in Chicago, you're going to be more like Houston. It's a lot. You're still going to have summer, you're still going to have day and night, you're still going to have summer and winter. But, the climate zones will shift. And if we just did drastic reduction in emissions, the problem is that, if someone in here were smoking a big cigar, and then they stopped smoking, it would take a while. You'd still be able to walk into the room a few hours later and say, God, somebody was smoking a cigar in here. Because it takes a while to clear out. It takes our atmosphere on the order of 1,000 years. 1,000 years to clear out. So if we completely stopped burning any fossil fuels today, we still would continue with a warming climate and sea level rise.
And you're talking worldwide, not
I'm
just the
talking
US.
worldwide. Okay, so this trend would sort of plateau out. And so we're looking at different models that kind of range from plateauing out and maybe in 1,000 or 2,000 years.
So the Winter Olympics are going to be pretty much a dinosaur in a couple of years,
You just have to move a lot farther.
Well, the ones in Seoul are in one of the coldest cities they've ever been in, the next one, so there you go.
Okay, so who's been holding their hand up the longest? Who hasn't had a question? Hal, you had your question.
It was a long time ago.
A long time.
I was just making the observation that given this jet stream diagram that you've got up here, even with this extreme, it looks like where we live in San Diego are still going to be good places to live.
That's probably true.
That's probably true.
Well, and except for the sea level rise and increase in San Diego is a lot less susceptible to sea level rise than Florida is. And, most of what I do revolves around ports and harbors and measuring winds and waves and currents and tides for the maritime transportation industry. And most people in that business are talking about, okay, how do we adapt to sea level rise and climate change because of all of the things that Jackie was just talking about, that even if everyone in this room reduced their carbon footprint, as Dave was suggesting, people in China are not likely to follow suit, or in other countries. And so we have to figure out what we're going to do to adapt as much as we are to figure out what to do to try to prevent climate change.
And you're right, the effects will be a lot more closer to the poles than closer to the equator.
So Howard says we're out of time. Let's